Hello, my lovely students. So, welcome back and thank you for tuning into our third screencast. We ended off, we had gotten as far as understanding how to get to a regression equation or the line equation, also known as a model, a line model. And the model represents the relationship. So regression means relationship. Regression is related to the word relationship. The relationship between two variables. And the one variable is an independent variable, and the second variable is a dependent variable. So it is something, when a change happens in the independent variable, we expect to see, we wanted to test to see if there was a relationship between the independent variable and something that we believe depends on the independent variable, which is the y variable. So looking at this example here, a lecturer wants to use the number of hours that a student studies for an exam to predict the final mark. And in this example, the hours is the independent variable and the final mark is the dependent variable. And so, well, if you watch the previous two screencasts, you'd know that if you have a set of data, you'd be able to determine or come up with this, and that is our model or our regression equation or our line equation. And what this means is our gradient is +3. Now, a gradient of +3 means that for every 1 unit of positive change that happens in the independent variable, we expect to see a positive, that plus represents a positive change in the dependent variable of 3. So I'm going to say that again. For every 1 unit that the independent variable x changes, goes forward, then we expect to see a positive 3 units change in the y variable. And that is what our gradient means. And the intercept in this case means 12.5. It's either marks or percent. I don't think I've stated here whether it is, I've just said the mark. So the student will have 12.5 marks if the student has absolutely none study time or no study time, no independent variable. When the independent variable is 0, and in this case the independent variable is study time, then the marks will be 12.5, and that's what that means. Okay, so what I also just want to point out is that there's actually a couple of different ways to write the same thing. And here I've actually written down. I've got two different ways to write it, and I'll point out a third different way. But let me first discuss these two. As you can see here, these two are actually the same thing, but in this example, the gradient I have first, and then the intercept, and in that example, I have the intercept first and the gradient first. Now, the reason why we would do that, and Excel would typically give it to us as this bottom one, but the reason why we do that is, say for argument's sake, that the intercept was 0. So, well, this it won't be the case in study, in terms of study time and grades, because you can't get a negative mark. But if you have, for example, planning time and expenditures, or no, profit. Yes, profit and time. I think I pointed out, I showed just an example of the market day, where I told you that that was an example that a previous class had done, and they looked at the relationship between planning time, so the amount of times that students plan and the amount of profits they made. Now, in that case, your profit can be 0. We all understand this. One doesn't only need to get a positive profit. Sometimes if you make a loss, then your profit is 0. And so at 0 planning time, which in that example was my independent variable as well, or time was also my independent variable, but planning time was the independent variable x in that example, the profit could have actually been 0 or less than 0. The profit could have been 10 minus 10 rand, which is also a loss. And if I have something like that, then I would have to write it out as y is equal to minus 10, for argument's sake, plus 3x. And that looks clumsy. That looks clumsy to start. Now I know my handwriting is now also leaves a bit to be desired. So let me just try and write that over and in a neater way. Let's write it over here. Y is equal to minus 10 plus 3x. But that looks very clumsy. So instead of writing it out like that, what we then do is we swap the two around. So it looks much nicer. It looks much nicer if we then write instead y is equal to 3x minus 10. But it means the same as this. And that's what I try to highlight by showing you that. And in the case of that, say for example, this with the intercept is 0, what it really then means is the line looks something like that. We still have a positive gradient. Now, positive gradient, as we explained, one change in x is so many changes in y. So y will still be going up with every positive change in x. But the intercept where the independent variable is 0 is below 0 for the y variable, which is the dependent variable. And now that also being said, I want to point out something else that you could that you could see. This is a linear positive relationship. There are occasions we can have a situation where the gradient is 0. And when the gradient is a 0, what that means is that the line will look like that. So for every positive change that we see in the independent variable or x, we'll see a negative change. So y will be going down. As x goes up, y goes down. And this is called a negative linear relationship. This, on the other hand, is a positive linear relationship. The other kind of relationship that can exist is where there's no relationship. But you'll pick that up very quickly when you do a scatter plot. And then, of course, your line, you'll see with the line, this value will obviously, you won't be able to get this equation. Or this equation won't be, the model won't be valid. Okay, so I just wanted to point that out, and this is what we know as interpretation of the model. So by looking at the model, we can interpret what it means. If we understand what the gradient is, and we understand what the intercept means. Now, once we have that, then what we're going to do is we are going to use this information to make predictions. So an example, a prediction example, is where we can substitute any value, not any value. I'll explain the last thing before I end the screencast. I will explain how far we can go. But we can substitute a x value or a y value and then calculate the corresponding x or y value. Now, let me use an example to try and explain what I mean. If you, in this case, it was hours and your marks. If you, for example, wanted to predict the final mark of a student that studied 10 hours, you will substitute the 10 where that x is there. And you would then say, use the rest of the equation, which is 12.5 plus 3 times that substituted x or independent variable, which you are interested in, 10 hours, what would that student's mark be? And then it's a very simple mathematical calculation to do that. Of course, it's 12.5 plus 30. And the answer is, of course, 42.5 marks. Similarly, if we wanted to do it the other way around, we could do that as well. So if a student wanted to obtain a certain pass mark, or if you knew, for any other example, if you knew what the value of the dependent variable is that you want, then you can work out the value of the independent variable. And in this case, the independent variable is obviously the amount of hours that the student needs to study. and we use the same formula, but we just change the way that the formula looks, because this time we are looking for the x and we're not looking for the y.
So what we do is we move some things around.
This time we want to obtain the x, so we can move this whole, this is a product of x and the slope. If we move this to this side of the equal to sign and we move that to that side of the equal to sign, then what we have is we have b0 minus, that positive sign will be cancelled, minus y1. And if we move that to that side, then that becomes minus x times the slope. Now, to get, this is a product, so to get rid of that, we would divide this whole part of the formula by b1, and that would cancel b1 out. However, what we're sitting with now is we are sitting with a negative x on this side, and of course b1 minus y, which is the known value that we have for the dependent value variable. But to get rid of that negative, we would then just rewrite it without the negative. So it would look like x is equal to that. We've gotten rid of a negative there, so that y becomes positive, whatever the y is, and that intercept now becomes negative divided by b1. And so that's how you see we use this formula, which is a variant of that formula, to determine an independent variable value. Given a dependent variable value, in this case of 75 mark path, we'd put the 75 marks in the y, the known y, or the known dependent variable, and using the line formula, what we've calculated for our intercept and for our gradient in our model, which is this over here, we'd substitute those two in, and we can do the sum accordingly. 75 minus 7.5 divided by 3 is 21 hours. Okay, so now we're nearly at the end of that, this part of the work, the regression part of the work. We know how to interpret a linear model. We know how to make predictions for both the x and for the y using a linear equation or a regression model if we're given that. The last thing I want to tell you is about interpolation and extrapolation. When we use a regression model for prediction purposes, we can only consider the relevant range of the independent variables when making predictions. So what I mean by that is you will obtain a data set. So let me get to this graph over here. You will obtain a data set, and in your data set you will have a number of values for x. Whatever the values for x is, they start at a particular point, and let's say they start here. Maybe I should use another color coding. Let's say they start over here and they end over here. And for dummy sake, let me make up a number. Let's say this is 3, and I'm thumb sucking any value. This is 3 and this is maybe what, 8.
And I used a bit of magic here and I just changed my 3 and my 8 to look better. What happens is I get this 3 and this 8 from my data set that I used to develop this model. Remember, I had a data set and I used that information to develop this model. And these are values, x values, so independent variable values. And this is the lowest independent variable value, and that's the highest independent variable value in my data set that I used to create this model. And so I am only, what that means, the interpolation and extrapolation, means that I am only allowed to use this model to make predictions within the range of the lowest value for an independent variable and the highest value of an independent variable from a given data set.
So I cannot make a prediction where this x is 2 and believe that the y value that I'm going to obtain is going to be correct, because that would be extrapolation, because 2 is under 3. Similarly, on the higher side as well, I cannot make a prediction where I have this value, this x value, as something higher than 8, if this, for example, was the range of my independent variable. So I'm running out of time now, students, so I'm going to end this screencast, and this is the last of regression. The next two screencasts will be on correlation.